So today's topic is Vo5G. So Vo5G as in voice over 5G. Earlier, we already seen some kinds of voice services like we use in our phone in 2G where we use GSM, 3G where the access technology is WCDMA, and 4G where we use VoLTE. So this is a kind of a new service, Vo5G, which hasn't been yet launched into the market. It's still being in the development phase, but probably within 2 or 3 months, it will come into the market. And so this one is the next, we are calling it the next generation voice services. And this will be a kind of new interactive call services, which will present with plethora of new features for the voice call. So far, whatever we have seen in our classic kind of calling, so it will be a kind of new experience. So let's have a little bit of overview of this view of 5G today. So we will discuss the evolution of this view of 5G, what is the motivation behind it, what are the various kind of voice solutions and the migration path towards this view of 5G from 2G, what are the coverage aspects of it, what kind of value addition is being done through this view of 5G, and what are the career prospects and various job opportunities involving this view of 5G. So far, I will use this term VO5G along with some other terms, which mostly I would use the VONR, which is the, I would say, the maximum part of this VO5G. But VO5G doesn't mean VONR. VO5G means somewhat a little bit more than VONR. Anyway, I will explain those terms in the later slides. But VONR, let me just explain quickly. VONR is voice over NR. So we are calling this next generation, this fifth generation technology as 5G NR. So this voice over 5G NR, it's called VONR, just for your understanding. So let's understand what's behind this VO5G. What is the motivation behind this VO5G? So if you see, you can probably see this kind of charts, the two charts over here. One is the device subscription, another is the technology subscription. So device subscription consists of basically some immobile devices like computers, tablets, these kind of things. Then there are the feature phones and the smartphones. So if you see the trend, you can see that over the past few years, the feature phone trend, the use of feature phone trend has been decreasing. And that's been taken over by the smartphones, which are being new kind of smartphone, various smartphones by various vendors, various companies, OEMs are being provided. So that particular smartphone is kind of taking over this. So feature phone use is decreasing. This is one point. Another one is the technology subscription. What kind of technology is being in use? So if you see this particular chart, you can see that the 5G is being used increasingly. Still, the 4G is being taken the largest market share, and then 3G, but 5G is still being used. So there's a projection of, say, another 5 years up to 2026 from the last some 10 to 12 years, so 2011 to 2026. So you can see from this trend that 5G market share will be increasing, smartphone market share will be increasing. So basically what we understand from this, so we understand that users have migrated from traditional handset to smartphone for new and better experience for the services provided by the operator. Hence, it is imperative that the operators need to enhance the mobile broadband network capacity. By the year 2026, it is estimated that networks need to be capable enough to handle close to around 250 exabyte per month of data, out of which you may say around 75% content will be in video. To handle such kind of huge volume of data, definitely need some massive kind of network, which 5G will provide. So operators are deploying 5G to handle this massive data speed, this massive data capacity, which is upcoming. And 5G will provide the higher spectral efficiency to handle this kind of data. Now, smartphones will not select a 5G radio access unless they can detect a voice service. So that means that voice must be supported in all the 5G evolution steps involving smartphones or any kind of voice-centric devices. Let's see some another aspect. So here you can see this technology population, as I was saying, that 5G is being, taking over the market share. So comparing the other 3GPP cellular technologies along with LTE, you can see that over the years, in the coming years, till 2026 has been projected here, it is estimated that 5G will be close to around 60% of the total population area covered. So, yep, yes, it's going to be a huge. And parallelly, if we see the VoLTE subscription, the voice services in 4G, this is also drastically getting increased. So voice is still the mainframe. So we are using phone, we are using plethora of services in our phone, but voice will still remain the basic services. Unless voice, no, phones will be just toys, just an internet device. So yes, voice needs to be there, but this VoLTE subscription indicates that yes, if we are growing on 5G, then 5G definitely need a voice service. And that voice service is this called Vo5G, and mainly it will revolve around VoNR or voice over NR. So this is a particular summarized over whatever we have discussed in the last two slides. So mobile broadband capacity needs to be enhanced for the growing demand of higher data speed. Subscriber migrating from traditional feature handset to smartphone for better experiencing those services. To handle such a huge volume of data, the operators are deploying 5G network as 5G now offers higher spectral efficiency and better latency. Smartphones will not select a 5G unless they can detect a voice service in the 5G radio access. Addition of 4G voice engine, addition of voice engine in 4G network through VoLTE, and then the huge growth of 5G. So these are the summarizingly, these are the points which are, you can say, the motivation behind VoNR, or let's say for that particular term, Vo5G. So let's just get ourselves acquainted with the VoNR a little bit. So what is VoNR, or what is 5G VoNR? So VoNR, or voice over new radio, it's a new calling this is a calling services over this new generation, the 5th generation technology, where with the help of this IMS, the IP multimedia system, you can experience a better quality call. Why it is important? It is important because of whatever I just mentioned, that because of this increasing market share, we need to have something on 5G, some kind of voice services on 5G. So that's why VoNR is important. And in addition to providing voice services, it will provide plethora of other services, which we will discuss in the later slides. How is 5G VoNR different? It's not that particular different with the other legacy technologies, as in VoLTE. It's mostly similar to VoLTE, but with a little bit of difference. We will discuss that. But definitely, it's a lot more different than the 2G calling services, than the 3G calling services. And how does it work? So basically, 5G VoNR needs a new kind of core, which is completely different than the legacy core, which will enable these voice services in 5G radio access network, along with your very old plain vanilla IMS, which is enabling the 5G voice services. Some interesting facts that VoNR, so you can say benefits as well. So VoNR provides faster call setup times and noticeably better sound quality. Your minimization of dropped calls, you have higher capacity, you have higher bit rate, rather I would say this is what you will define the high definition call, and then better quality media, provided you are also having video. So you can say that VINR as well, video over NR. Let's just have a quick overview of a very small overview of the evolution, which is still being followed from the 2G to 5G. So what we were using in 2G, we are using GSM along with CS core. So GSM to CS core, and then there's a point of interconnect through which various nodes are getting connected. After that, there's a little bit of upgrades, then CS core becoming PS core, where we have SGSN and GGSN, which combinedly we are calling it PS core. So this is mostly, these terms are being familiar in 3Gs. So then where is 3G? Here is this 3G, WCDM. And WCDM is the access technology for 3G. So WCDM is connected to PS core for data and CS core for the voice. Still legacy. Now we got ourselves a little bit upgraded through which one? LTE. So LTE is the 4th generation technology along with PS core. So LTE doesn't inherently have voice capacity within itself. So how we are providing the voice capacity to voice enabling capacity to LTE? We have another node which is called IP multimedia subsystem or multimedia telephony. This is the one which is responsible for enabling voice over LTE. So the way we are using VoLTE today in our phones, without IMS, it was not at all possible. So now still LTE is our legacy. We are waiting for the next generation. So what is the next generation technology? It's 5G. This is today's condition. 5G is being introduced, but still the core is legacy, and we are connected to IMS. So yes, we have voice services, but through legacy technology, whereas 5G is kind of a data booster. It's providing you high data speed. So you have the high data speed, but still you cannot call through 5G. And then there are some other non-3GPP access technologies like Wi-Fi or this kind of thing. So the provision has been there to integrate this as well. So now the flavor comes for voice, which is the PS core. So you have a new core for 5G, but still it's PS core, it's not CS core. What do you need? You just need a connection to IMS. So it's same as in VoLTE, but with this new upgraded PS core and a connectivity to IMS, you can make a very high definition call over 5G and plethora of other services, other interactive voice services. Let's just look this evolution from the standards point of view, because all these structures are being standardized. Some standards bodies are there who are standardizing this kind of structures. Like ITU, probably you have heard of these bodies, ITU, International Telecommunication Union, 3GP, Third Generation Partnership Project, and GSMA. So if we see the standardization progress, we can see that there's a one line for ITU. So ITU is basically making the specifications or providing the requirements, I would say, or rather. ITU is providing the requirements, 3GPP is making the specifications based on the requirements. So if we can see that around 2000, so 2020, IMT 2020 requirements, which is the official name, the IMT 2020 is the official name for 5GNR. 5GNR is actually 3GPP nomenclature. So for ITU, it's IMT 2020. So this IMT 2020 requirements has already been put forward in 2015. And then 3GPP started working on the specification from 2015 and 16. And in 2017, the release 15 specification has been frozen. Release 15 is the first release from 3GPP where 5G NR has been mentioned. Now 5G NR, the basic 5G NR requirements have been divided in two phases. One is release 15, which is called the work item phase 1. Another one is release 16, work item phase 2. So basic requirements are being divided over this release 15 and release 16. Mostly the NSA part has been dealt in release 15, and release 16 consists mostly the SA part. NSA means non-standalone, SA means standalone. Then after this release 16, will there not be any 5G related work items? Yes, there will be, but then those will be enhancements. So the basic requirements are covered here. So what are being covered here in the basic requirements? I would say just from the voice perspective, because there are other data perspectives also. So for voice perspective, the voice and video communication services specification has been defined. The EPS fallback, the RAT fallback, these have been defined. We will discuss these terms in the later slides. Then it's also defined the IMS related services in release 15, where it is being defined how to connect through IMS. What is the connectivity? What is the how location information is being carried over 5G? These kind of things have been defined here in the release 15. What is being defined here in the release 16? Release 16 consists of the coverage optimization of VONR and the 5G to 3G, directly from 5G to 3G SRVCC, these kind of things. And from IMS related specifications, like how IMS will support the network slicing, where we are using the services in different slices, and the service-based interfaces. So this is a little bit overview on the standardization progress. So in June 2018, the standalone standards have been frozen within this release 16, and the network commercialization started around, say, in the first quarter of 2020. So it's, you can say, more than 1 year. there are kind of deployment. So when commercialization has been started, when I'm saying commercialization, it means NSA commercialization, non-standalone commercialization. Standalone commercialization, it's just being started in 2021. So what are the configurations, how you are deploying, how the operators are deploying 5G? Operators are deploying 5G in certain configurations. So from basic VoLTE, as you have today in 4G, to VoNR, there are certain other configurations also. We are calling it middle phase supplementary solutions. These solutions are also there. We'll just see those solutions in the next slide. So first one is VoNR, as in voice over NR. Second one is EPS fallback. EPS stands for Evolved Packet System. Third one is RAT fallback. RAT stands for Radio Access Technology. Fourth one is 5G SRVCC. SRVCC stands for Single Radio Voice Call Continuity. And then you have your plain vanilla age, old VoLTE and CSFB. Okay, what are these? So VoNR. VoNR is your basic native voice over 5G radio access, where you have both voice and data services. In NR, you do not need any other technology. It's kind of a standalone network. So how do you understand the standalone network? Let's take example for Reliance Jio. Reliance Jio have only 4G network. So you can say it's 4G standalone. Reliance Jio doesn't have 2G, doesn't have 3G. It need not to go back to 2G or 3G. So 5G standalone, that means you can only have this 5G network. There's no need for go to 4G. EPS fallback. So evolved packet system fallback. That means whenever you need to have a call in 5G, you are basically falling back to your legacy 4G. So if you need to call, you need to go back to 4G. So that's why it's called fallback. EPS fallback, EPS is basically 4G core, the 4G, the EPC system. Now there's RAT fallback, radio access technology fallback. Basically, these two are same. Then what is the subtle difference? The subtle difference is when you are going for EPS fallback, that means you are moving from 5G to 4G, basically the core gets changed. That means you have your next generation core. Now, whenever you want to make a call, you are moving back to 4G core. In RAT fallback, okay, you need not to move to your 4G core, because if in the cases, if you already have 5G core and you are moving back to LT, because you can already have LT connected to your 5G core, you are moving back to LT, then this kind of situation is called RAT fallback. 5G SRVCC. What is 5G SRVCC? So SRVCC in single radio voice call continuity, that means that your voice call will be continued. It will not get interrupted. So this 5G SRVCC means you are moving from 5G to 3G. So this particular thing is still being studied, and I would say this may not will materialize. Why? Because already operators have started phasing out 3G. In India, Airtel, you can see there's no 3G network for Airtel. They have already phased out. So if the networks are already getting phased out, this is all only for commercial purpose. In worldwide also, operators have started phasing out. In Germany, Vodafone have already phased out your 3G. So there's no point keeping this working. So it's an work item, it's an option just for the sake of an option. And then you have VoLT or CSFB, which is a native voice choice in your 4G or in 5G NSA configuration, non-standalone configuration, where you need 4G along with 5G. Let's just see these 5G VoIP solutions from a construction point of view, from the architectural point of view. So this one is your option 3 flavor. I would rather say this is option 3X. This is a particular flavor of option 3. This one is the basic choice of 5G NR NSA configuration, where you can have 5G as a data booster, but you are making your call through 4G. So EV is connected to your EPC via LT. NR is for data. Then the next option and the later options all involve 5G core. This one is legacy core with a little bit upgrade. So that's why it's a 5G EPC. EPC it is, but it's 5G EPC. So then there's option 4, where the EV is connected to 5G core via NR. You have LT, but this LT is called ELT or evolved LT. Why? Because this LT is connected to 5G core. So what kind of voice services you can have here? You can have VoNR. Definitely you can connect to NR. So you can have VoNR, you have RAT fallback, you can have VoELT as was in VoLT. What is the next one? Next one is option 7. Here EV is connected to 5G core via ELT. So this is kind of a mirror image to this particular configuration. You can see particularly. Here, what kind of voice services are possible? VoELT, because you have connected to ELT, and then VoNR, because you have NR and NR, you have 5G core. So yes, VoNR is possible. Next one, option 5. This is VoELT, because EV is connected to 5G core through evolved LT. So yes, only one kind of voice services is possible, that is VoELT. Next one is VoNR. This is our target configuration, our desired configuration, where EV is connected to 5G core via NR. So you can have the VoNR as an only option. But out of all these options, we are not at all concerned with all the options. We mainly concentrated on 3 configurations or 3 options. So the 3 main scenario: voice in EPS ENDC, the first one, the option 3. What I mentioned, voice in 5G core with EPS fallback, multiple configurations possible, and then our very familiar native voice over new ready. So we have multiple challenges, multiple kind of challenges in terms of radio optimization, in terms of end-to-end optimization, in terms of monitoring your KPIs, your events logging, your tools, what kind of user equipments you will use. So we will see in a little bit detail. So let's take the first one. So voice in ENDC. So what does voice in ENDC means? Your voice will go through LT, your data will go through NR, and it will reach the IMS, because IMS is needed. But IMS is not at all concerned about what kind of things are going here. So it's kind of a black box to IMS. So you can just attach IMS to each of the configuration, which I will show in a few seconds. Next one is EPS fallbacks. Multiple configurations possible. For just mention, I have just mentioned 3GPP option 2, but multiple configurations have been possible where you can have NR for data, but whenever you need to make a call, you need to fall back to LT. So this is called EPS fallback. And this EPS fallback is nothing but, you can say, 5G counterpart of 4G CS fallback, where from 4G, if you do not have the voice capability, if you do not have VoLTE, you are falling back to legacy 2G or 3G. So what is CS fallback in 4G? EPS fallback in 5G. The next one is VoNR, where you can have LTE as well in this VoNR network. So, but your voice and data both can go through NR. Interesting thing, you can notice that you can directly remove this LTE network. So it is a standalone network where VoNR is possible. Let's just see the network scenario. In which of the scenario for each of the 3 cases, let us see just the network scenario quickly. So the first network scenario for the ENDC, you have a spotty or limited NR coverage. You have NR, but this is kind of a spotty coverage, and your NR is not equipped with the new generation core, the next generation core. And you have VoLTE layer, you have 2G and 3G layers. So this is the kind of network scenario you have. So what kind of solutions is possible there? The ENDC solution is possible. Let's just see the solutioning. This is the solution. So where EV is connected to both LT and NR at the same time. So the control signaling is going through LT. You have user plane and control plane connected to LT, but only one user plane connected to NR. So NR can act as only data booster or data enabler. So it's just an extra data booster. You need some high data speed, you move on to NR. You need the voice services, you just fall back to LT. Or rather, you do not need to fall back, rather, I would say. You just make the call through LT. So this is your voice over LT with ENDC. Why ENDC? It is called Ultra NR dual connectivity. So it is dual connectivity. The EV is connected to LT as well as NR. Why ENDC? Why EU try NR? Because LT here is master. That's why LT is mentioned first. EU tra NR. If NR is master, then it will be NEDC, NR EU tra dual connectivity. So that is the way the nomenclature is being done at 3GPP.